guys, how you guys doing? Another video on motors. Again, continue with our industrial course. If you guys have been reading through your chapter 8, a lot of the motor controls, they do talk a lot about different types of controls. Here, for example, they have a relay, control relay. Here, motor coil, timer, motor, and timer again right here. So again, you have multiple functions that these guys do. Today I'm going to explain a little bit about relay coils right there. If you guys have gone through your book, it gives you some examples of some relays, some timers, stuff that we'll be using out there, and then they give you the schematic right here for a relay coil right there. So that's it right there. I have it written up here, and I'm going to explain to you guys a little bit of how that works out right there. So when we're talking about relays, they come in different styles. They have single Icecube relays. These are called Icecube relays because they kind of, I guess, they look like ice cubes, I guess. So they're considered Icecube relays. So here you have a single, you have an 11 pin, and you have a 14 pin relay. So these right here, and then I have a block for an 8 pin. So yeah, they come in single, doubles, which is the 8, the 11, which has 3 options, and then the 14, which has 4 options. So again, they do have different blocks for them right here. So this is, you know, colors and stuff like that. They do come in different styles. For example, this one right here, I drew it right here. It would be, if you notice, it does have, it's supposed to have a couple screws on here. I picked up the wrong ones, but anyways, should have a screw here, which would be this guy. Then it's got these 2 screws right here, which are these 2 screws right there. Those 2 little screws would be your A1 and your A2. So that would be these 2, A1 and A2. So that's your motor coil. According to what the relay coil is requiring, that's the voltage that you would give it. For example, this one right here, the coil for this guy is 24 volts DC. So you'd have to give it 24 volts DC for this guy to activate. So that means you would bring in power in. So power would come into this bottom screw. So if you notice 1, 2, 3 screws, 1, 2, 1, 2 are these, your A2. And the bottom screw is where your power that comes in. Now this requires 24 volts, so you can bring different voltages depending on what this guy can handle. Again, some of these can go up to 480, so depending on what they are. But mostly these are lower voltage types of relays. So coming in power, and then you have your options: normally closed, normally open. So that's what's going out if you want it normally open or normally closed. Here's another example of another, here's actually an 8-pin relay. Again, you have your coil, 2 and 7 are your coils for this guy. So that would be these 2 are your coils. That would be activating that guy. Again, depending on what voltage the relay requires, that's the voltage you're going to put in for that. Then you have your incoming, which again could be different voltage. Doesn't have to be the same voltage as the relay coil. So you have your incoming voltage. So you have one option. So 1 is normally closed to 4 and normally open to 3. That is your option there. And you can come into 8. And then you have your normally closed to 5 and normally open to 6. So again, it gives you 2 options right there. So 2 powers coming in, 2 options either normally closed or normally open, normally closed or normally open. Well, in reality, it's 4 options, but again, most of the time you only use 2 options. But there is situations where you might use all 4 options for that scenario right there. And then here's another one, the 8-pin relay, 11-pin relay. Again, the coil, again, they all have coils. So this one, the coil is 2 and 10. This one was A1 and A2. This is your 2 and 7 is your A1 and A2. This one is 2 and 10 is your A1 and A2. So those are your coils. Again, so your coil would be something like this. This would be a round 11 pin. So that's what this guy would look like. If you notice, it even has a little kind of key looking thing right there. So it's got the 8 pins right there. And again, an Icecube relay with 8 will actually fit right in there. And again, you have to make sure that it goes right on the key, because if I try to put it without the key, it's not going to go in. It has to be the key. If you notice, the pin relay, it's got the little notch right there. This has to go exactly on here, and it matches right in there. And again, you mount it onto your DIN rail. This right here is what we call a DIN rail right here. So this little run right here where we put all our stuff. So this guy will just mount on here. If it cooperates like that, just mount on there again, and you're able to take it off. All you gotta do is put a screwdriver here, and it comes off pretty easily right there. But so again, that would be a DIN rail. So again, 11-pin relay. Again, your coils 2 and 10. Your in option is 1, is normally closed to 3 and normally open to 3, so that's one option. 6 would be normally closed to 7, normally open to 5, another option. And 11 is normally closed to 8 and normally open to 9. So again, 3 options. This one gave you 1 option, 2 options, 3 options, and if you have if you have this one right here, and this one gives you 4 options. So again, all you're doing is adding one more. It's 14. So you would have 3 more screws, and again gives you a few more options. How does it work? How does a relay work? Here's an example of how a relay actually works. Well, the internal workings of a relay right there. Again, the coil, again, your A1 and A2 is your coil. That's where your power come in. Again, it wraps around your aluminum wire, wraps around a metal casing. Again, right there, it creates a magnetic field. When you give power to this magnetic field, it creates induction, and then that magnetic field actually creates enough magnet that's able to overrun this spring. So this spring right now is pulling this guy up, but when this magnetic field actually activates, it has enough power to bring this guy down, and now the normally closed is now normally is hitting the normally open right there. So it changes positions, and this guy would be hitting right here instead of that. When you turn off power, this guy, the power goes off here, so this magnetic field goes away, and then the spring is stronger, and it brings it right back up, and it goes to the normally closed position right there. Again, this would be your in, your power coming in. That would be your common power comes in, and then your 2 options. So this one represents this one screw coming in, and then again you're normally open and normally closed. So that's what's going on with this right here. So that's an example of the relays. Here's one inside, what it looks like inside of it. If you take a look, see it is you can barely tell, but it's making contact to this this terminal right here. And if you move it, and now it's making contact over there. So once the magnetic field, it makes it touch over there, but you let it go, it goes right back into that position right there. So again, the spring pulls it back to its normal position. So that's its resting position. When you activate power, it changes the position. Now this is where it's making contact, but as soon as you let it go, it goes right back into this. So again, you have your coil inside of there. You have your A1 and A2 coming in. They go, so your power activates this power, gives voltage through this coil inside of here, and you're able to change the positions for this stuff right here. So again, you can barely tell, but as long as it doesn't make the other contact, now you have a different position right there. So it does make a difference with that right there. Again, 11 pin, each pin, it has its own different contact. It does different things. So these guys are actually, some are connected with other ones, depending on what position you have it going to right there. So it depends again. So that's how that works right there. So hopefully that helped out a little bit. Hopefully it didn't confuse you guys with coils. Again, we use coils for quite a bit of stuff. We even use the same pins that we use for coils. See, this happens to be an 11 pin, same as this one right here. So I can put this one on here, and it fits right into the same position. If I can find where is it? Right here. If I can get into the same thing, or I can use a timer. A timer is another type of relay, so it's kind of the same concept as that right there. So I can put the timer in here. Now, again, the same coils, the same thing. If you notice, my coil here is 2 and 10, same as my relay was. 2 and 10 is still my coil, and then you have 1 coming in, closed to 4, open to 3, 6. Again, this one they have for a switch right there, so it's a little bit different. But again, 11 you have normally closed to 8 and open to 9. So again, pretty much the same symbol as this right here. It's almost exactly the same thing as this. What's going on right here. So again, these you have different types of timers. You have on delay, off delay, and different types of timers that we have right there. So we'll go through some of these, how we start using them. Again, there's different scenarios while we'll use this, but again, once we get into the lab, you guys will begin to try to practice some of this. But again, I just wanted to give you guys a rundown of how relays kind of work, and how, you know, what's inside of them, what's going on with a lot of them. Hopefully that helped out. These right here are called contact blocks. So these are the contact blocks where the relays actually go in. Again, if you notice, they almost look exactly the same thing, but this one happens to be an 8-pin. and only has 8 pins around it. This one happens to be an 11 pin. So this 11 pin will not fit in here no matter which way I turn it, because it doesn't have enough holes for this guy to go in, because that's only an 8 pin. They do make Icecube relays that go into this, but this one happens to be an 11 pin. It goes perfectly right in here. So depending on which one you're going to be using, that's what you're going to have. So thank you. Hopefully you guys enjoyed the video. Again, let me know what you guys think, and see you guys in the next one. All right? Thank you very much.